Hello guys, welcome to my YouTube channel. Now this is the second video of this playlist which may be an important topic or a question for your subject in computer science, whether you are doing engineering or some course related to computer science. Then you have to learn this subject, which is called computer oriented numerical methods. Now we are going to study an important topic of the subject, which is known as partial pivoting. So let's discuss. Now let us see what is partial pivoting. Partial pivoting is a method which is used to calculate the solution easily and quickly without causing any error. So the actual definition of partial pivoting is: partial pivoting is a numerical technique that involves swapping rows during the solution of linear systems to improve accuracy and stability by choosing the pivot element strategically. Partial pivoting is used in numerical methods, specifically in solving systems of linear equations through methods like Gaussian elimination. Gaussian elimination, we all are well known if we have been in the mathematical field, or our subject is maths. Then Gaussian elimination is used in maths also. So we use this method in computer science also. So partial pivoting is used in Gaussian elimination method and many more numericals in order to find the solution. The idea is to prevent numerical instability and improve the accuracy of the solution. And the third, this helps prevent division by very small numbers, which can lead to numerical errors and instability. In conclusion, or in short, we can say that partial pivoting is used in calculations of numerical methods in order to find an accurate solution to the question or to the problem without causing any errors or any wrong answers. Now let us see how it is done. The first step of doing partial pivoting method is to initialize. Start with the augmented matrix, that is A and B, where A is the coefficient matrix. Here the A is the coefficient matrix and B is the column vector on the right hand side. Now the next step, that is the second step, is for each column, that is K. The first point is identify the pivot element. Find the maximum absolute value among the elements in the column below the current pivot position. This involves scanning the column from the current row to the bottom. So this step involves the scanning of the column from the current row to the bottom row. Whichever row we are selecting, we have to scan from that row to the bottom row, which will be the last row. Now the second is to swap the rows. If the maximum absolute value in the current pivot row, swap the current row with the row containing the maximum absolute value. Now the second step, we are doing the swapping of the rows. We are interchanging the rows. Now the third is to eliminate below the pivot. Use the pivot element to eliminate all entries below it in the current column. Perform row operation to make the elements below the pivot 0. Since we have selected a pivot by swapping the rows, now the main aim of this method is to make the elements below the pivot 0. Now the third step is repeat for the next column. We have done the second step for a single row. Now we have to repeat this method that is given in the second point, that is of swapping the rows and making the row below the pivot 0. Now we have to repeat the next column. Next, each and every column should repeat this same step, that is second. Back substitution. Once you have an upper triangular matrix, perform back substitution to find the solution of the system of equation. Now let's see the partial pivoting condensation algorithm. We have to write the algorithm for it. Pivotal condensation algorithm. So the first step is to start. As we all know, every algorithm starts with the first step, that is to write start. And the second step is for each column in the augmented matrix, find the pivot element in the current column. And Now the second point here, the subpoint, swap the current row with the row containing the pivot element. Now the third step, for each row below the current row, subtract the multiple of the current row to eliminate the coefficient below the pivot. Now the fourth and the last step is to stop. This is a small algorithm, pivotal condensation. It's not a tough one, so we can understand by this. Thank you very much for watching this video. Like, share and subscribe.